Welcome back everyone. Now we are going to learn about the ammeter. Well, what is the ammeter? Well, first of all, let's start with the question because questioning makes me perfect. Don't you think so? Well, I think so. Yes. So let's ask the first question that why we use the galvanometer. Well, this is an instrument like all the two instruments that measures current. Well, it is named as in the favor or frame of ampere. Well, in short and simple, what Ampere discovered it. We use that the unit of A in his legacy or whatever you can like to call it. Ampere discovered this, and we are studying the current. We study current in a circuit, and now we are going to make it. Okay, so that's all the for the theory thing. Okay, so let's begin making our ammeter. Well, what the ammeter actually do? It measures the current. What is the current? Well, when electron moves in one direction, it leaves the current in other direction. So if you treat the current as negative, you have to treat the oh, you have to treat the current as positive. If you treat the electron as negative, that is very much obvious. Electron is negatively charged, so we treat it as negative. So you can think of it like action and reaction pair. So action pair is the electron itself, and the reaction pair gives us the current that we use in our instruments everywhere in the world. Okay, so that is the measurement purpose. But we are using galvanometer, so let's bring the galvanometer into role. So in this case, and this is the resistance that RG. Remember, it's inside, but I'm making it outside. Well, when you start making the things yourself, you will understand the basic logics that why we do so, and why it is simple and why something is happening. When you learn electrical technology and further sections in the digital electronics and learn precise things and all the such, okay, when you learn the things deeply, you will understand everything because everything is significant, very much significant. Nothing is just like it is happening just because of good design. There is a precise engineering behind that all. Now, do you remember RS? This was our what? This is our shunt resistance that we can vary. Well, I'm again and again showing this shunt resistance or variable resistance. This is because we have to various resistance. Sometimes it is symbolized as like this. This is also called as rheostat or shunt resistance or variable resistance, whichever way you like to call it. Generally, in electronics books, you will see the word rheostat, STAT, rheostat, in which we make an arrow over the resistance so that we can vary the value of the resistance. That's all it means and nothing else. Okay, so what we need in this case? Well, in this case, we want our shunt resistance to be very minimum, theoretically zero. So the theoretical value of the shunt resistance in the case of ammeter is actually zero omega. Omega is the symbol for the resistance. We will study that in electrical technology if you have not seen it before. So don't worry about that thing. It's just a number. 0 omega or 0 ohm. Okay, so what is actually happening? What we want here is to understand the nature of current. Well, if we have two pathways, imagine that we have two pathways, and what we are, we are the current. So for a few moments, I am making you the current, so you can imagine the potential and the current and the power that you have inside. Wow, how nice it feels, right? Okay, so current is having two possible paths. Let's make two resistance because resistance is everywhere. either in life or in the circuits. It's everywhere. We cannot develop, grow, or move without the resistance itself. You believe it or not, but that's the reality. So let's call it R1 and let's call this one R2. If you imagine that R2 resistance is far more greater than R1, the current itself goes very less or maybe zero through this path, and more or completely through this path. If you make it precisely zero or theoretically zero, which is not possible as I told you, but if we imagine it's zero, the entire current will move in this direction, and in this direction no current will move. But practically it do not happen that something becomes absolute zero because of our manufacturing purposes and atomic things and all that. So we can assume that most of the current moves through the 0 point. Now what is the purpose here? Well, the purpose here is the current is moving through this way, this passage. When the current moves, majority of current moves this way, we are able to calculate the measurement through our galvanometer precisely and quickly. So theoretically zero means all the current are flowing through this way. So when all the current are flowing through this way, we are able to calculate our galvanometer's reading quite easily. Well, you might be thinking that why I made that in parallel, but I want to answer that in the next one. And for now, I want you to think that, what's actually happening here? But for now, I think you have got the idea that what is the ammeter and how it's working. So precisely what we require is to flow the current in one direction, and that current will going to give us the reading. Okay, I will not make you wait till the next one. I'm going to reveal the secret in this one itself, as we have studied in the galvanometer already. Okay, so why I just said that I'm going to answer that in next one, to put you on little pressure and make you think that what's that much difficult? Well, nothing is difficult, my dear friend. Okay, so let's understand this in a more significant way. Well, like I just said, let me open a new page so that we can start with a fresh thing. Okay. Um, yeah, we are ready now. So this is the galvanometer. This is the internal resistance of the galvanometer that we called RG. Now this is the resistance or the shunt resistance that we call RS. This is the battery that we have, let's say 10 volt or 15 volt or whichever volt, we don't care about that. So this is voltage. So this is the current that we have. So if I say this is theoretically zero or minimum, let's say, so most of the current that is coming from the battery itself will go in this direction majorly. So where are the electrons going? Well, that is the real question. Electrons are going, majority of the electrons are going in this direction. And imagine that electrons are going to hit the surface of the galvanometer. Tish, 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 tish. That's what I'm sounding like. I don't know. Like the balls, if you throw so many balls on the wall, it will sound like this, all the things. So what actually happens because of that excessive negative charge? Galvanometer will slightly deflect. Well, slightly? Yes, slightly. Because as I told you, in the real world, the shunt resistance cannot be actually be zero, and the size of the electrons are very, 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 very small. On contrary, we sometimes used to call it that if you imagine a golf course, and if you have a ball, that is nucleus. So you know what we imagine, that what is the size of the electron? Well, just put dot somewhere, maybe this dot is even bigger than the electron. So that is the electron. Well, very small, right? Its weight itself is 9 multiplied 10 to the power minus 31 kg. Now you can imagine, I cannot even say kilo or giga or iota and all that because the unit is so small. Minus 31, right? It's very, 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 very small. So, if very, 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 very small electrons, but still millions and millions of electrons hit the galvanometer, it will deflect. It will show the deflection, and that will act. The equal amount of the current must have gone from the path, from the alternate path that we have prepared with the RS route. Equal number of electrons that have gone here produce equal number of current. Let's, for example, let's imagine it like this. If you send 5 electrons in this direction you are going to get 5 ampere. Well, this is not precisely, but you can assume it like that because each electron is contributing for the current itself in the equal value. Okay, I think you understood the concept of ammeter. And that's all about the ammeter. Now you do not have to wait for the next one to understand that what ammeter is actually doing and how it's actually working. So can you see that how galvanometer revolutionized the thing? It is just a current sensitive instrument, but after that we have traveled a long journey. Let's see one after another that we had traveled. Okay, we start with this. Okay, this is galvanometer. Galvanometer is a current sensitive device working on the attraction and repulsion basis of the magnetism and solenoid properties and all that we have studied. And after that we studied the voltmeter. Voltmeter was a fantastic instrument prepared by the volt. It's you can treat it as counting of the energy, and we use in our home 220 to 240 volts. But the most important thing is we prepared the voltmeter itself from the galvanometer's concept or the galvanometer itself. Well, we can do both ways. So we use the galvanometer itself and just use the resistance, which is shunt resistance. You can go in the market and can ask for resistance, and you will find it's the one of the most cheapest thing you can ever get in electrical instruments. If you want a little higher, you will buy a capacitor. If you want more high, you will buy a transformer. Well, in the real life, I also rated that resistance are very free and very much cheap. That resistance, something stopping you, is very easy to get, and capacitor, that's holding that energy, holding that potential inside of you and understanding it, is a little expensive. You have to dig inside yourself, and when you have to go to complete transformation, it is the most expensive thing and most rewarding one either. The same thing happens for the electrical instrument itself. That's how they're priced. I don't know why, but that's precisely it's going to be. Okay, so the last thing that we have studied was ammeter, on which we have seen that ammeter is having A written as A in the form of the ampere. Who created that ampere? Well, you will learn about the ampere and volt so much when you study about the electricity and electrical technology. So they both were one of the founding fathers of electricity, you can say. Well, let's say you can say 5 ampere or 15 ampere and all that. You can check out your electrical bulb or any appliances. There are written few things, which is volt, ampere and watt. Well, now it's turn for the watt. That is our energy meter. So we're going to learn about the watt in the next one. So I hope you have enjoyed this till this point. So see ya in the watt meter. Take care and God bless.